All right. Welcome to the next, latest, and greatest webinar on CIS-210, Principles of Computer Programming 1. I am Professor Lusby, and I wanted to create another webinar recording here where we are focusing in on week 8. This is your last week of the course. Um, the finish line is in sight, and we definitely want to finish strong. So that's what I want to do right now is dive into week 8, what it is that we need to do. Uh, Again, I assume everyone is familiar with the classroom at this point. All the previous weekly recordings are at the top. And of course, the most important link is this handy dandy GMC virtual desktop that has everything you need installed in order to complete these assessments. And I will be demonstrating how to use that here very shortly. So let's go down here to week 8. And we're going to see that week 8 is about single dimensional arrays. Okay. This is a very powerful data structure that allows us to use a single variable name for multiple pieces of information. Um, and that comes in handy because we're able to build scalable code that uses these array variable names. And the way that we access each piece of information in these variables is using what's called an index. And an index essentially is a numeric way of accessing the data inside of that array variable. Okay. And the book, I think, does a pretty darn good job of explaining arrays, gives a lot of really good examples as far as, right, we have to declare an array just like we would declare an int or a double or a class. Obviously, we have to declare them in memory before we can use them. How to assign values to an array, how to access each one of those individual elements using an index value. Um, all of the main things that you really are commonly done with an array are listed here in the beginning. Um, and yeah, it does go into, once we're able to store all of this data into an array, that does give us the ability to search and sort the information that's inside of the array. And that is also a huge step forward, right? Because one of the number one reasons that we uh, create computer applications is to sort information and be able to search for it, right? I guess what we used to do before computers is a bunch of file cabinets, right? And we had to be really good at storing records in file cabinets. Well, now we can take all this information and put it into an array. And there's other data structures that we can use other than an array. Uh, but it's one of the, uh, it's a common data structure that allows us to store multiple pieces of information uh, under one variable name. Okay, and once you get to a data structures and algorithms course, you're going to see that there's a lot of other really cool data structures that we can use uh, other than an array. And every data structure has a pro and con to it. And at some point, we need to pick the right tool for the job, right? And an array is one tool of many, or one data structure of many that we can use. But for sure, it's very common in industry, and we do need to know how to use it. So that's what chapter 8 is all about. You definitely want to look that over, look at the examples in the in the chapter, and get comfortable with it. All right, what else? Yeah, here's our overview page. Basically states what I was just talking about. Uh, we're talking about arrays. We're talking about sorting techniques. We're talking about searching techniques, and that's that's what we're going to cover here in week 8 in chapter 8. Um, in particular, there are different kinds of arrays. There's single-dimensional arrays. There's multi-dimensional arrays. In CIS-210, we're only going to be talking about single-dimensional arrays. Once you get to CIS-211, I believe the first week, you're going to be using multi-dimensional arrays. But don't worry about multi-dimensional right now. We're only focusing in on single-dimensional arrays that have one index value. Yeah, let's talk about searching. Let's talk about sorting these single dimensional arrays. You're going to see that there are particular ways or algorithms that uh, we can use in order to search, in order to sort. There's a lot of different sorting algorithms that we can use. Probably, I don't know, over 100, but I would say maybe 10 or 12 of those are common in industry. I think this particular textbook talks about like a simple bucket sort um, and a simple binary or a binary search, and maybe even a linear search. Oh, here's some sorts. Selection sort, insertion sort. And again, at the end of the day, all these sorts do the same thing. They sort the data and the output's the same, but there's a couple of different ways we can sort that data, and that's what it's going to get into here. All right, enough about that. So that's what we're focusing in on this week is chapter 8, all about arrays, searching, and sorting. So we're getting into the fun stuff. Week 8 supplemental material. Yeah, again, a couple more links. In fact, I think this is the Java arrays tutorial, same link from a previous week. But there is a good tutorial here from W3 Schools concerning arrays. So again, take a look at that. If it confuses you, don't worry about it. Always come back to the textbook, email me, reach out, and I'll see if I can clear things up for you. Okay, this is optional supplemental material. What else? All right, so what's the nitty gritty for this week? Yeah, we have a discussion, just like we always do. We'll take a look at that here in a second. We have a programming assignment, just like we always do. We'll take a look at that. Just like week 4 and week 6, we do have a part 3 of your CIS-210 project where we are going to complete it in its entirety. So you do have 2 programming assignments this week, not 1. And of course, the final exam. I don't believe it's comprehensive, but I do believe that it goes over the last 4 chapters that we've gone over, and we'll take a look at that here in a second. All right, so let's take a look at week 8 discussion forum. A lot of you have already started this and are working on this, so that is really great news. But they want us to complete, looks like programming activity 2 in your textbook, chapter 8, and it's all about searching and sorting arrays because super duper important concept for industry. Being able to search and sort information using a computer is, I don't know, probably 3/4 of the reason why we invented computers to begin with, and the math reasons as well, right? But we have so much data now that being able to search and sort that data, just think Google, right? Just think social media, just think Amazon. We have so much data and products now that, yeah, being able to search and sort that data is a super duper important concept. All right, so what do they want us to do here in programming activity 2? Well, if I pull it up in our book, we will see that they want us to write a method to perform a sequential search, also known as a linear search. One of the most straightforward ways of finding information in an array is something called a sequential or a linear search. And basically what that means is that it starts at the beginning of the array, let's say at the first element, and then it walks, it iterates through each element of that array, looking for whatever it is that we're trying to search for. All right, kind of a brute force method, right? It's not very optimal. Literally, you're looking at every single item in the array until you find it. And there are other searching algorithms that are more efficient than that. But at the end of the day, we got to start somewhere, and a linear or sequential search is one way to do it. It's just not very efficient. That's all from a runtime perspective. All right, what else? Number 2, write a method to implement the bubble sort algorithm. Right. So one of the most straightforward sorting algorithms is something called the bubble sort algorithm here. And for sure, a lot of you are new to both of these things. And we're going to be going over this solution here in just a second because I want to show you what important algorithms like this look like, especially when all of a sudden an array is involved. All of a sudden we have loops. Um, a bubble sort even has a loop inside of a loop. Um, and when you're new to all of this, we're kind of getting into data structures and algorithms here. Um, this is kind of a little bit of an advanced topic. Some schools kind of break this stuff out and put it in a data structures and algorithms course. Other schools do kind of wrap it in with the programming course because at the end of the day, when you go to program for industry, you do need to know how to do these things. Um, so anyways, that's what we're talking about here. They kind of give us a high level overview as far as what's going on with the bubble sort and what the outer loop and inner loop look like. Um, but at the end of the day, this particular programming activity should produce a GUI that looks like this. They're trying to give us a graphical representation of what it looks like when we do a bubble sort. Notice that right now they've basically just kind of populated um, all of these values with random values, right? Looks like between 50 and 80. Some of them are in order, some of them are not. That's why we see this bumpy road here. And once it's done sorting, well, we should see the lowest number over here, the highest number over here, and then everything in between is in sorted order as well. So part of this programming activity is that we implement this bubble sort so that happens. The other part is the sequential search button where you click on it and it's going to ask you, well, what number do you want to look for? And you put in a number and you should see it kind of look at each one of these elements in the array looking for whatever number it is that you typed in. So that's the idea here, is that we want to implement the logic behind these two buttons here. All right, well, how do we do that? There is a particular Java file that we need to look at inside of this code for this activity called array practice 2 controller, and it has two methods that we should implement. One called sequential search that does when we click on it here, it's going to call this method here, and another one called bubble sort. When we click on this here, it should call this method down here. All right. All right. How do we do this? Let's go into the GMC virtual desktop. Everyone should know how to do that by now. Provide your credentials. And you should see something that looks like this. Once we see this, probably, all right, first thing we're going to do is let's log into the classroom inside of the virtual desktop. The reason being that for this particular activity, right, programming activity, we need to get these files that implements this GUI. So go ahead and log into the GMC virtual desktop inside of the virtual machine, all right, in the classroom, and then scroll down here and let's go to, where did he go? Here. Well, that's the virtual desktop, excuse me. Let's go down here. CIS-210 Programming Assignment Frameworks. So let's go ahead and click on that. Let's download the file. Inside the file, we should see all 8 chapters that are in the course. We drill down into chapter 8. We drill down into programming activity 2. And we are interested in these guys here. So organize them by type and highlight the fxml file and all the Java files underneath of it. 1, 2, 3, 4, 5, 6, 7 files. Go ahead and minimize that, and let's go ahead and launch NetBeans, and you should see something like this. Maybe your projects tab looks a little bit different, but regardless, we're going to do the same thing we always do, right? File, new project, nice descriptive name. What is it? CIS-210, week 8 discussion. Oh, whoops. I skipped a step. Sorry about that. Ignore that. Somebody went down here to samples. Java application. Give it a nice descriptive name. CMP, CIS-210. This week 8 discussion. Leave this as is. Uncheck this. Uncheck this. Make sure these are unchecked. Go ahead and click on finish. This should feel very familiar because this is what we've been doing for the past 7 weeks. All right. We have an empty project, empty default package. That's exactly what we want. The reason being that we downloaded these files. Make sure you highlight all 1, 2, 3, 4, 5, 6, 7, right? And you can use the left mouse button to do that. Just hold it down. Once they're highlighted, hold down the left mouse button, drag and drop on top of default package, release the left mouse button, and you should see the files. Again, these projects are starting to get more complex, right? We've got multiple files. For sure, this is more like what you would see in industry, right? Each one has their own class in it. And again, I would love to go over this, but that would be a few hours worth of information at least. Just know that they did use object-oriented design. Every one of these Java files has a unique class in it. This is the fxml file that produces the GUI when you launch the program. So that's why it has to be present. All right, but what they want us to do is here in array practice2 controller.java, we scroll down here, they want us to implement this method, sequential search, and this method here called bubble sort. And just as a gut check, let's try to run this before we put in that code. And we should see something that looks like this. And if we hit sequential search and we put in a value and hit OK, notice that it does nothing. All right, we click on bubble sort. Notice it does nothing. Why is it doing nothing? Because we haven't implemented these two methods yet. All right, so how do we do this, right? And they do give us some pseudocode here. It's super high level. They're basically just saying make sure you call animate, where I is the index of your current array element, and at least that will show you on the GUI where you are in the array. That's what this animate is doing, or once we use it. The other important thing to notice is that, well, this sequential search returns an int or an integer, and this int or integer, right, is supposed to be, if a key is found, the index of the first element in the array whose value is, we basically want to return where that value was found in the array. That's what this return value. We shouldn't be returning 0. That's why nothing's working right now. We need to return where exactly in the array is this key located. All right, that's the idea here. And then for bubble sort, well, there's no return value. There's no parameters either. So I assume that, let's see here. Yeah, I is the outer, J is the inner. Well, where's our array? Source ARR. There it is. So we are supposed to sort whatever data is inside of this integer array. Okay, notice it is private. We only want to be able to, because of encapsulation, all of this is private. However, we can access it inside of this class, right? Inside of all of these methods, we're using those private member variables. It's just we don't want anybody outside of this class using those member variables. So that's why we declare them as private. And then, of course, yeah, the bubble sort also needs to use animate ij, where I is the outer, j is the inner, and that's going to show us on the GUI as we're sorting things, what's going on. All right, so how do we go about doing this in particular? Well, right before this webinar, I took a gander and came up with one possible solution. Is this the only solution? No. But I want you to at least see one possible solution. And when you're new to programming, uh, learning how to read code and interpret its behavior, right, is just as important as writing the code. And so I wanted to show you this one possible solution and make sure that we can look at it and really understand what it's doing. All right, so if we take a look at this solution, we see that number one, we've got a for loop set up. And this is typical for arrays, right? Whenever we have an array and you want to look through that array, well, you want to start at the beginning or the 0th element of that array. And that's the other thing that throws off a lot of students who are new to programming. 1 is not the first element of the array. 0 is. All right. In computer programming, the 0th element is the first element. All right, so that's why we're starting at 0. And then we're basically going to keep incrementing by 1. This I is going to keep incrementing by 1 until we get to however large the array is. So array.length or arr.length will basically automatically return whatever the length of the array is. So if there's 30 elements in the array, then it will return 10. If there's 100 elements in the array, then it will return 100. So we're setting up a counting loop here that's going to go from 0 to however big the array is. Now, inside the loop, how do we know we're inside the loop? Because we have these nice curly brackets, right? This is defining the for loop scope. Inside the loop, we're going to call animate number 1, just so that we see what's going on in the GUI, and it's going to pass I. Well, remember that I starts at 0, so the first time we're in the loop, we're going to call animate 0, and that should tell the GUI to probably highlight that first element, the 0th element red. Then 122 says, well, if ARRI is equal to key, remember the whole purpose of sequential search here is that we're looking for the key, and we want to know, well, where does that happen in the array? And this is how we access an element in the array. You call out the array name, and then in between the square brackets here, okay, you have to use square brackets with an array. In between the square brackets is, well, which element inside of the array do you want to look at? And in this case, we're saying the ith element, right? And the ith element is defined up here as the our for loop counter, right? So we start at 0, we look at the 0th element. Is that equal to the key? We go to 1, well, is 1 equal to the key? And notice what happens is, if this is true, let's say ARR0 is equal to 10. Let's say we're looking for the key number 10. If that's true, it's going to execute the very next line of code directly underneath of it, which is return I. And the reason we want to return I at that point is, well, we found it. We found that key that you're looking for at this ith location. There's really no point in looking at all the other elements in the array, or at least here there's no point. In industry, there might be. You might want to do that, right? Maybe this key happens multiple times in the array, in which case we'd want a different algorithm to look for all of those keys. But here, for this programming activity, it says, look, just let us know where the first one is. Where the first one is, and that's why we can say, well, when we find it at the ith location, let's just return it, and let's get out of this function altogether. Hey, I found it at, the 5th index, maybe I was 5. Well, then let's return the value 5 and be done. Now, the other important thing to notice is if we keep looping here, right? We start at 0, and then we go to 1, then we go to 2, then we go to 3, and we keep going all the way to ARR.length, and this is finally false, right? Because let's say we have 10 elements in the array. Well, 10 is not less than 10. So this is false. It's going to jump over all of this. So it's looked at everything in the array, and this never happened. So it never called this. This never happened. At the bottom, if we jump out of that loop, that means we've looked at every single element inside of the array, and we didn't find any match for this key, right? We've looked at this never happened. So if this never happened, we never found the key, and we've jumped out of the for loop, at that point, we're going to return a -1, which basically signifies, hey, I, I was unable to, right? There is no such thing as a -1 index. So -1 just lets whoever's using this function know I didn't find the key. And it even specifies that up here, right? If key is not found, return -1. So that's the point of this statement, is that, hey, I've looped through all of the values in the array, never found the key, so I'm just going to go ahead and return -1. This is known as a linear search or a sequential search. When you literally go through every single element of the array, looking at every single one of them, that is known as a linear search. And again, it's one way to do it, but imagine if we had 1,000,000 entries in the array. Imagine if we had 1,000,000,000, right? It's not a scalable solution. There are other data structures that we can use, like binary trees, that we don't have to look at every single element in order to find an element. All right, but that's way beyond the scope of this class. This is just the most straightforward and efficient solution. All right. And at the end of the day, that's what separates a programmer from a computer scientist. The computer scientist will pick the appropriate data structure and algorithm and not just code and make it work. All right. All right, but again, that's beyond the scope of this course. That's in your data structures and algorithms course. It's also a really, really fun course. All right, bubble sort. Notice that for this bubble sort, basically what we want to do here is when we're looking at elements in the array, we want to start comparing, well, is this value here greater? Well, let's say we want to sort in ascending order. So we want a small number here, and we want the biggest number over here. What we want to do is compare, let's say, this one and this one. Well, if this is smaller than this, because, right, we want all the smaller ones on the left-hand side, then swap the two. So put 80 here and put 60 here. All right, this is how the bubble sort works. Then it says, okay, compare this one and this one. Well, if this one is smaller than this one, then swap the two. Then compare this one and this one. And you keep comparing and you keep swapping until you go all the way down every entry inside of the array. All right. And what ends up happening is, and when I run this, you're going to see that the large values bubble this way and the small values start sinking this way. That's kind of why it's called a bubble sort, because one of the either ascending or descending values is going to bubble towards the right. Or I've seen other bubble sorting algorithms demonstrated where this is presented vertically instead of horizontally, and it does look like the big ones are bubbling to the top. All right, and this is one way to implement a sort, and this is called a bubble sort. You need two loops. The first loop is responsible for, right, this first one that we're looking at, and the second inner loop is going to look at all the rest of these compared to whatever this element is here. All right, so that's why we have these two loops, is because we're constantly comparing two elements in the array to each other, but we don't want to compare the same one with the same one. All right, and so that's why you see that I starts from 0 to array length -1, right? Because 0th is the first element. And J is 0 to array length -I. So once I gets, let's say, here, right? Once I is here, then J is just going to be these elements. There's no reason for us to use these anymore because they're already in sorted order. So that inner loop should always start the next one after I, which is J, and only look at these guys. So once you get here, you're only looking at these three. Once you get here, you're only looking at this one. All right. And there's some good YouTube videos. Well, I'll show you in a second. Once we run this and you see this animate call happening on the GUI, it's going to make more sense what this bubble sort algorithm is doing. All right, number one. So we got two loops. One's an inner loop, one's an outer loop. So these are nested counting loops. J is nested inside of I. All right. Now, inside of the inner loop, remember that we want to look at, well, is J greater than J plus 1? Right? Is J greater than J plus 1? And if so, if this is true, then you want to swap them. You basically want to take whatever is here and put it here, and whatever was here and put it here. And this is very typical for a swapping algorithm. You do have to use a temporary variable. You can't just say, well, ARJ is equal to ARJ plus 1. That's not going to swap the two. And in fact, you're going to overwrite one inadvertently. So to swap two items in an array, you have to use a temporary variable to remember the first one. Then you set the first one equal to the second one, and you set the second one equal to the temporary variable. All right, so there's some swapping logic here, and then we call animate. All right, so let's see this. Let's see this work. I'll go ahead and run this. And if I push sequential search, and let's say I want to look for number 62, it's going to, right, loop over all the elements in the array and return if it finds number 62, or if it doesn't find 62, it's going to return -1. So I'm going to click on OK here. And here, this is what the animate's doing. It's showing you which one it's looking at, and then boom, it hit 62, it returned 8, and it stopped the search, right? Well, what if we put in something like the value 5? Well, 5's not even here. Oh, well, it won't let me. Fine, let's put in 30. I don't think 30 is there, right? Put in 30. Notice it's going to look at every single one of these, looking for 30. It's not going to find anything. All right, so this sequential search or linear search goes through the whole array. There are better searches, but this is one way to do it. Bubble sort, if I click on bubble sort, watch what happens. Notice that, I wish I'd go a little bit slower. Notice that the big value here is bubbling to the top, right? Every time it looks at two of these, the big value starts bubbling to the top. And notice that once we get to the end here, it doesn't need to look at these anymore because they're already sorted. Okay, so that's why you see I and then J is equal to I, what is it? N minus I. It's a lot of math involved, for sure. All right. And the good news is that, look, a lot of computer scientists have already come up with these algorithms for us. And it's just a matter of finding which one you want to use and implementing the code. All right. And for sure, this code is listed in your book. I definitely don't expect you to come up with this off the top of your head, but I do expect you to be able to implement it where needed, but not for this discussion. For the discussion, I want, make your best attempt at it, make a post concerning it, and a lot of learning goes on just doing that. All right, so that is the programming activity 2 for the discussion. Please play around with that and answer these questions on the discussion board. All right, what else do I need to do? Week 8 programming assignment. Okay, so here is the week 8 programming assignment. It is definitely a little bit larger than we're used to, and well, you're in week 8, so go figure. Here, so we've developed command line applications. What was it? Week 6, I believe. We had to, where was it? Week 6, right. Do you want to enter the current weather criteria or quit the program, right? So this is a simple command line interface with 2 menu options. Well, now, this week, we also have a command line interface, but we have 5 menu options, not 2. All right. And each one of these menu options does something a little bit differently. Number one, we'd enter number 1 in our menu if we want input new daily weather data. So we click on, we select 1, and then it asks us, well, what's the weather data? Give me wind speed. We type in wind speed. Give me daily temperature. We type in the temperature, and then it basically lets us know, hey, that's been recorded for day 1. So we should be able, it looks like, yeah, up to 10 days worth of weather information. So for sure, our array needs to be at least 10, and we should be able to run this menu option 1 10 times. If we go to do it an 11th time, well, then it should freak out because there's not enough room, right, for an 11th option. But that's what number 1 does. Allows us to enter daily weather data. Number 2, display all recorded weather data. So if we select number 2 here, number 2, then we should see something that looks like this where it lets us know we're looking at the weather data table. It lets us know, well, this column is the day, this column here is the wind speed, and this column here is the daily temperature. And originally these were lined up underneath of each one of these things, but it looks like somehow the formatting got screwed up. But I mean, I guess as long as I see these 3 pieces of information, here's the day, here's the wind speed, here's the daily temperature, here's the day, here's the wind speed, here's the daily temperature, I would be happy uh, as long as all the information's there. Try to make it as pretty as possible. I would like it to line up with the column headers here, but if that's too much trouble, don't worry about it. All right. So this is option 2. Basically, everything that's in the array, everything that's in the weather data array, we want to output it to the screen. Option 3, display recorded weather data sorted by temperature. Aha. So originally we put the data in like this, and notice that the temperature is 60 for day 1 and the temperature is 80 for day 2. Well, if we select 3 and we sort by temperature, and it looks like they want the highest one to go first, well, then we need to list day 2 and then day 1. And imagine we have 10 days worth of temperature information. That temperature column here should all be sorted from highest to lowest for this one. All right. So when we hit option 3, yeah, we need to run a sorting algorithm on this weather data and then basically print it out to the screen just like we did up here. All right. For number 4, search recorded weather data for wind speed. So if we select number 4, it's going to ask us, well, what wind speed are you looking for? And maybe in this particular case, they're only interested in days with 50-mile-an-hour wind. So at that point, we do a sequential or linear search, right, through all of our data, and we look, all right, is there any of these that has a wind speed of 50? And the answer is yes. Day 1 here, right? Day 1 has a wind speed of 50, so that's what gets output here, is, hey, I found a day with a wind speed of 50, and here are my results. And again, there's some column headers here above saying this is day, this is wind speed, this is temperature, and it'd be nice if those lined up, 50s here under wind speed and 60s here under daily temperature, but whatever. As long as the data is there. And please don't get too creative here. In fact, don't get creative at all. When I run your program or when I see the output of your program, I want to see something that looks exactly like this, please. It's going to make my life way easier when I'm evaluating, and even in industry. The customer is going to let you know what they want the interface to look like. You may think it's the ugliest interface in the world, but they don't care, right? That's what they're paying you to do. So please try to implement this particular application as is, as far as the command line interface is concerned. All right. And then option 5 is quit application. And if you select that, it's going to exit out. The other 2 important parts is you need a weather data class. Well, that sounds familiar. Didn't we do that in week 7? So that part should be done from week 7. And we want a NOAA weather tracker class with a main method that basically does all of this. So we do want a project with two files, those two Java files. How do we go about doing this? All right. So what we want to do is go into, well, I would suggest going into the handy dandy virtual desktop. Go ahead and launch NetBeans. Let's create a new project like we always do. File, new project, Java application. Let's give it a nice descriptive name. Week 8. This is your assignment. Okay, week 8 assignment. Leave this as is. Uncheck, uncheck. Hit finish, and we should have a nice empty project here, and we do. Oh, you know what? We can start with the files from week 7. So I'm actually going to open up the week 7 project. Where is it? Week 7 assignment guidance. Maybe week 7 assignment. Let me open that one. And let me see, is this right? Yeah. We've got a weather data class, which it told us we need to use. So I'm going to copy this. I'm going to paste this, and you don't have to do that, but it'll save you some typing. Oh, but this is not right. Let's close this project. Let's open up. All right, regardless, for sure you need a weather data class. And for sure we need the, was it NOAA weather tracker class. All right, ignore this warning. Click on finish. And at this point we have oh, please don't freeze on me. Oh, shoot. All right. So at this point, we have the two classes that you're going to need for your project. All right. Let me show you some guidance. All right. I did exactly what I just showed you. Create a new project. Created these two Java files. And here for, oh, this is tricky. I don't really want to show you whether, well, no, this is guidance. Yeah, that's right. I didn't want to show you the answer for week 7. All right, so this is the guidance for week 7. We have a weather data class, and obviously a lot of you have already completed this and have filled this in, and that's great news because you've got your weather data class done and defined. All right. For the command line interface, right? That is inside of NOAA Weather Tracker. That's kind of the whole point of NOAA Weather Tracker. I came up with this pseudocode. Let me just kind of walk you through it real quick, and then, well, quick's relative. All right, so for sure, we always want to create our constants and variables at the top. Obviously, it seems like we need an array of 10 weather data objects, so I would suggest creating those here. A variable called current number of weather data stored, because the thing is that just because we have an array of 10 weather data objects doesn't mean that we've filled them in yet, right? It could be an empty array. So we need some sort of counter here to store, well, how many elements have been stored inside of the array. And that's why I'm calling that out here. And you can give it a different name if you like, but I do like descriptive variable names. All right. You need some way of counting how many elements are inside of this weather data array. Next variable called menu select. Well, yeah, we need to know which menu item the user typed in so that we can have the appropriate logic and do the right thing. And then, of course, this wonderful scanner that we all know about that allows us to read in data from the user and do something with it. And maybe you need some more variables than this. This is just me thinking high level. For sure, you're going to need those, but maybe you might need a couple of others. All right, so then we get to the input part here, and we need to display the menu, right? Before we can ask for the input for the user's choice, we need to show them the menu. And like I said, don't get creative. Please output exactly what was shown in the requirements, and that's what is here. And then use that scanner object here in order to store whatever the user types in, right, for that menu selection. And I like to put variable names in here because I can talk about those variables in the pseudocode below. Do you have to use this exact variable name? No, just make sure it's descriptive so that when I'm reading the code, it makes sense. All right. So at this point, we've displayed the menu to the user. We've obtained which menu selection they want, and we've stored it in menu select. All right, now comes the process part of the algorithm. And what we want to do here, very similar to week 6, right, create an event-driven loop that's basically going to keep looping until menu select is 5. Why menu select is 5? Well, 5 is the option, right? That means you want to quit the application. So we want an event-driven loop, aka while loop, that's basically going to keep going until menu select is equal to 5, and it's going to start here, and it's going to end way down here. All right, that is the event-driven loop, here to here. All right, and then inside the loop, if we check and we see, well, menu select is equal to 1, well, 1 means we want to input new daily weather data, right? All right, so the user obviously wants to input new weather data. If that is true, because menu select is 1, we need to do a couple of things. First thing, very important, we need to make sure that, remember that variable up above called current number of weather data stored? We need to make sure that that's less than 10. All right? If it's greater than or equal to 10, well, that's bad, right? If it's greater than or equal to 10, we don't have any more room to store whatever that weather data is. So if this is true, if this current number of weather data stored is greater than or equal to 10, well, then we need to display an error and basically get them back to this menu so maybe they can do something else other than enter weather data. All right, so this is kind of a check to make sure that we're not going to try to enter more data into the array than it can hold. All right, now if it passes this check and this is false, well, that means we have room, right? Otherwise, if the condition above is false, then we have more room. And at that point, we can say, all right, now ask the user to enter the wind speed. Now ask the user to enter the temperature. And once we have that wind speed and temperature here, now let's use the array. Let's use current number of weather data stored. This lets us know where at in the array that we're going to store the temperature and the wind speed, right? Because if we haven't put in any data yet, current number of weather data stored is equal to 0, right? So what this is going to do is this is going to set the 0th object in this array and set its data. Well, let's say we stored five items already. Well, then current number of weather data stored is 5, and we're going to write it to the 5th slot of the array. So this current weather data stored is doing 2 things. Number 1, it's letting us know how much data is in the array, but number 2, it's letting us know where we can write new data when we find it. All right, so the combination of the array name and how many elements are in the array, we want to use that to store, to access the object that stores the temperature and the wind speed. All right, once we've done that, well, now we need to increment that current number of weather data by 1, right? Because we just added that weather data object or updated that weather data object in the array. So yeah, there's one more weather data object in the array now. So let's go ahead and increment this by 1. All right. So this is how we can input new daily weather, is these two critical lines, right? Is how we can update the weather object inside of the array. And then here is the end of the menu select equaling 1 logic. So from here to here, is that right? Yeah, from here to here, all of this we're only doing if menu select is equal to 1. All right, well, what if menu select is equal to 2? If that's true, then now here we want to create a counting loop. And this counting loop is going to go from 0 to current number of weather data stored, right? That's another reason why we're keeping this current number of weather data, is that when we go to look at the array later on, we can create a counting loop that lets us know how this variable lets us know how big that counting loop needs to be. So a lot of students who are new to programming, especially arrays, they remember to create this array, but they forget to create a variable that stores how many items are currently in the array. All right, and you can't with an array, you have to have both. You can't have one or the other. I mean, I guess you could look through the array and look for an empty slot, and then just assume that empty slot is available, but even that gets dangerous if you do that. All right. All right, so we create a counting loop from 0 to however many elements are in the array. We call that loop counter I. All right, and then inside of that loop, basically print out the data in weather data array I. So if the loop's going from 0 to 5, because we have 5 weather data objects, then print out weather data array 0, print out weather data array 1, print out weather data array 2, right? And as long as you have that toString method, wherever that went, here, inside of weather data, well, then when you go to print out weather data array 0, it's going to call toString and print out a nice, well, the string should look like this. Where'd it go? Where'd it go? Where'd it go? String should look like, oh my gosh, here, right? Something like that. It'd be nice if it was indented a little better, but whatever. Okay. So for number 2, we're just doing a counting loop and printing each element, each weather data element inside of that loop. All right, so only do this if menu selects equal to 2. Well, if menu selects equal to 3, if that's true, aha, here we need to sort that weather data array by temperature. And I said ascending, but actually I think it's descending order, because the requirements show descending order. In descending order. And again, the textbook has lots of good examples, but the good news is that I just showed you in the week 8 discussion solution, all right, if you remember that, here is an example of one sort called a bubble sort. You can use this. You can use this to sort your weather data, right? Obviously, the variables, your array variable is going to be a little bit different. You're going to use weather data array, but everything else should be, instead of using length, you're going to want to use, instead of using length there, you're going to want to use, where to go here, current number of weather data stored. All right. So here for the sort, where do we go? We're in menu select 3. We're using the sort. Reference the textbook there, the bubble sort, and basically you can copy and paste that code here or create a function down below and call the function down below. The requirements don't really talk about needing functions. So functions are optional, at least for this assignment, but for sure in industry, they would like to see all of this broken out into its own function below main. for sure. All right, but that's optional for this course. Okay, for number 4, so this is sorting, and then once we sort it, we do a counting loop. Inside the loop, we print out all the data at each weather data array, right? So basically, we're doing this exact same thing after we've sorted it here. All right, but for sure, you need to sort it before you can do that. That's the fun stuff. All right, for menu select 4, if that's true, ask the user which wind speed they want to search for, right? Very similar to our programming activity this week. And they're going to type it in. And once we have that, then we're creating another counting loop. So you see how with arrays, we're almost always, if we go with the most simplistic algorithm, we're always create an array or a counting loop that's going to loop through all of them. So we're doing that again here, even in option 4. And inside of this loop, right, this counting loop, we're going to say, well, is weather data array I, the ith element of that array, is its wind speed, right, because we need to call the accessor on the weather data object, is that equal to whatever the user typed in and called, I call it wind speed query here, but you can call it whatever you want. So is whatever this wind speed is of that weather data object, is that equal to whatever the user typed in? And if this is true, then we want to output that object to the screen for the user, right? We want to output here. If that is true, right, and you find the weather data item with the 50 mile per hour wind speed, well then showcase that weather data objects, day, wind speed, daily temperature. All right. So you will need to use, if you use the print here for that weather data object, it should go ahead and print out all 3 fields anyways. Okay. And then finally, if number 5 is selected, before we go there, you do need to display, if you don't use a do while loop and you use a while loop up here, you're going to need to display the menu again. If you use a do while loop, you can just display the menu up here right after the do statement, and you don't need to display the menu up here and down here. But again, some students who are new to programming, the do while loop, for whatever weird reason, they get really confused with it. I say just keep it a while loop, display your menu here, and display your menu here at the bottom of your event loop. All right. And then finally, if number 5 is selected, well, that's going to cause this to be, right, menu select is 5. It's going to jump out of this event-driven loop and then come down here and display, quit program selected, whatever, exiting. All right, so that's how I would go about, and again, this is one solution. If you know of another one, and as long as you can meet all these requirements called out here, and you run this and enter all this data, and it looks exactly like this, and maybe you put in a few more weather data items, and everything looks good, well, then you found another way to do it, and that's perfectly fine. You just got to make sure you meet the requirements. All right, you don't have to use this, but if you want some guidance, that's why I did it. All right, okay, so there was the programming assignment. Goodness, I am running long on time. Let me see if I can speed things up a little bit more. What else do we need to do for this week? CIS-210 project part 3. Yeah, we do need to talk about that. This is important. Part 3. So notice for part 1, you did this number part 1 and 2 of the course project. For part 2 in week 6, you basically did, I believe, 3 and 4. For week 8, you need to do all of this. And the good news is that you've already done, right? You've already done this. So you've got 70% I would even say 80% of the code done. All right. But week 8, you need what you did in the previous week 4 and week 6, and you need to meet these requirements too, 5, 6, and 7. And what 5, 6, and 7 wants to do is basically, well, if you do have a binary number, right, with a bunch of zeros and ones, then count the number of ones that's in that binary output. Number 1, count them, how many ones are there. But number 2, once you have that count of how many ones are there, call out, is it even or odd, right? So if there's 3 ones in that binary input, you're going to say, well, that's odd, right? If there's 4 ones in that binary input, you're going to say, well, that's odd. All right. And here's some examples, right? When your program runs, you should be asked to enter your name and a binary number, and it should format the name. Remember week 4, format the name appropriately. And then for the new week 8 functionality, it's going to look at this number, assuming it's valid, and specify, is the number of ones even or odd? And in this case, it's even, right? There's 4 ones. Here's another example. Well, here's Raphael. Here's another valid binary number. You format, this is the output, right? This is the input, this is the output. Here's the name formatted with capital R, and the number of ones here in the valid binary number is 3. That is odd. Notice here, last test, and I would advise you to run all 3 of these, or for full credit, I would like to see at least these 3 test scenarios. Here's the name, Jose, and here is the binary number. Notice this is not a valid binary number, but you still have to format the name and then say, hey, this is not a valid binary number. So you do need to implement all 7 of these requirements for week 8. Please, please, please remember to do this, right? All right, how do we go about doing this? Obviously, you're going to go in, and in the interest of time, I've showed you how to create a project, create a new project. That's what I did here for the guidance. Created a new week 8 course project, added a new main file, right? Here's the main file. All right, called it week 8 course project because that's what we're working on here. And here's some guidance concerning that. Here's kind of the variables I could think of off the top of my head, and this is one solution. This is not the only solution. This is one possible solution. Definitely need a variable to store the binary input that the user types in. Definitely need a variable to store when we look at binary input, we're looking at each character. So that I think that's why we put current value there in week, was it 6? Is binary lets us know if whatever that number the user typed in, if it's really a binary number or not, right? Is binary true? It is. Is binary false? It's not. And then finally, probably a variable called number of binary ones that's going to help us meet those 3 new requirements for 5, 6, and 7, right? We need to count how many ones we see in that binary number. All right, so that's for the constants and variables, part 1. Yeah, this is week 4, right? Ask the user for the name, for their name, right? Request the user to input their name. Obviously, you're going to use a scanner to do that, and then you're going to format that name. Make sure that the first letter is capitalized. All characters after that are lowercase. Remove any spaces or special characters. For full credit for week 8, I do want to see this. For week 4, you all didn't really know about loops, so I didn't really include that in the grading, but for sure for week 8, I will. For full credit, you do need to have logic that will do that. All right. Once you do this, go ahead and output that formatted name to the console. So that will meet, right? That's going to meet the, that's going to do this for us here. And then part 2 and 3, at least to me, it makes sense to combine them. And you're going to see from week 6, we're kind of doing the same thing, right? We're requesting the user to enter a binary number. Fine. We're going to grab the first character of that binary input string that the user typed in. and we're going to store it in current value. So again, this is the same that I recommended in week 6. Then we're going to create a loop that's going to go until current value is empty. So basically, we want to keep looping until that character, until there are no more characters, right, inside of binary input. So we want to create a loop that's going to keep looping over every character inside of binary input and grabbing that character and putting it into current value. And then once we created this event loop that's going to look at current value, inside of that event loop, well, let's look. If it's not a 1 or a 0, well, at that point, we know it's not binary, and we can set this to false and get out of the loop, which is optional, but a good way to, there's no reason to keep looping, but if your algorithm does, I don't think it's going to hurt it either. All right. So if the current value is not a 1 or 0, well, guess what? It's not binary. We're going to set it as binary to false. If it is a 1, if current value is a 1, here's kind of some of the new logic. If that single character from binary input is a 1, well, then let's increment that number of binary ones variable that we just added by 1. So this guy's responsible for remembering how many ones there are in the binary input. All right, so if that's true, if current value is 1, well, then we're going to increment number of binary ones by 1. So that 10 times fast. And then once we do these 2 checks, once we set either is binary or we increment number of binary ones, then we're going to grab the next character, binary input again, and it's going to come back up here to the top of the loop. And so we're going to do this logic here for every single character that the user types in into binary input. All right. So part of this was already done in week 6, or I showed it to you in week 6, the pseudocode. This part wasn't. This is kind of a new addition in order to count those ones, which is what we're told we have to do for week 8. All right. Now, once this finishes, there is some, this looks like week 6, but there is a couple of minor modifications. For sure, if we check is binary and it's false, well, then guess what? It's not a binary number, and that's what we're going to tell the user. It's not a binary number, and we see that here, right? If is binary is false, we say invalid binary number. If it is a valid binary number, then we need to either output even or odd. One of the easiest ways to do that is you can look at, remember that number of binary ones guy that we're incrementing by 1. If that modulus 2 is equal to 0, meaning if you divide that variable by 2 and the remainder is 0, then you know it's even. If you divide that variable non-binary ones by 2 and the remainder is 1, then you know it's odd. Okay, this is where the modulus operator comes in really handy, especially for even and odd detection. All right, and I think we went over modulus in one of the other weeks as well. Okay, so this is kind of my guidance here concerning week 8. Make sure that all requirements are met here, not just a few of them. All 7 of these need to be met by your week 8 submission for full credit. All right, and of course, don't forget the results document, right? You all should be well versed in how to create the results document now that has your name and class information at the top, then copy and paste the code directly underneath of that into the results document, then take screenshots of the code running under these different test conditions, take screenshots of those and include those in the results document as well. Same here with the week 8 programming assignment. I do want you to run all of these menu options. I do want to see your output and input for all of these memory options and those screenshots inside of the results document as well. All right. Okay, and then that's basically it, other than, oh yeah, the final exam. Oh yeah, and then you have the final exam. And the final exam, what is it? It looks like 25 multiple choice, 11 or 10 open response questions. Oh, 11 for a total of 36 questions. You do have 90 minutes to complete it. So for sure, you want to make sure you study before taking this final exam. You have one attempt, and make sure you submit when you're done. Otherwise, I can't give you any credit. All right. I think that's enough for this week. I just wanted to be very clear what it is that needs to be done for week 8 because it is week 8, and once week 8 is done, guess what? That's it. I submit grades and we move on to bigger and better things. So for sure, make sure you have everything in by the end of week 8. Discussions for week 8 are due by Sunday. I think everything else is by the last day of week 8. Okay, and that's all in your week 8 quiz, anyways. All those dates and times are called out in your week 8. Where is it? Here. That's all called out here. Week 8 deadline information. All right. Whew, that was a lot. That was a lot of information. I tried to get it out as fast as I could, as clear as I could. Please continue to, give me feedback, email me, like the video, comment, whatever. That's what keeps me going and is what helps me improve these videos. Okay. So have a great rest of your week. Definitely stay in touch if you need anything at all, and I'll see if I can help. Thanks.